Carbohydrates, beyond the basics. So everyone knows about the performance-enhancing effects of carbohydrate consumption before and during exercise, and the potential benefits in regards to recovery when consumed after exercise. To be honest, you can go to any blog or journal and read about that kind of stuff. But here at Sport Performance Explained, we like to bring something different to the party and obviously come at things from a slightly different angle. So rather than rattle on about the benefits of carbohydrates in relation to exercise performance and exercise intensity, I'll talk about the lesser known effects and benefits of carbohydrate in relation to athletic performance. So recently, carbohydrate intake before, during and after exercise has shown benefit in regards to immune function. So during prolonged, moderate to high intensity exercise, so we're talking 90 plus minutes, around 75% VO2 max, when nothing but water is consumed, it's likely that blood glucose levels will drop or become unstable. So blood glucose is tightly regulated within a range thought to be around 4 to 5.5 millimoles per litre by the homeostatic mechanisms of the endocrine system and the glucoregulatory hormones. So when blood glucose drops, the body releases hormones glucagon, cortisol, and adrenaline in an effort to increase concentrations. So these hormones are collectively thought of as stress hormones. I generally refer to them as being similar in character to Robin Hood because they steal from the rich and they give to the poor. So they scout around the body looking for glucose and they take it from storage and pump it back into the blood. So these stress hormones directly suppress the actions of white blood cells. So this obviously leads to a degree of immunosuppression, increasing the risk of infection. So it's generally advisable that not only from a performance enhancement standpoint, but also from an immune function and general well-being standpoint, that athletes consume a carbohydrate-rich meal before exercise. And if exercise is 70 to 90 minutes or more, then an additional sports drink during exercise would be recommended too, in order to prevent those drops in blood glucose and to maintain normal blood glucose levels, to prevent that stress response. Utilizing evidence-based nutritional recovery techniques will also benefit, if you don't consume anything after exercise, so if you don't refuel after exercise, your blood glucose is also likely to drop and result in a similar scenario, so a similar stress response and reduction in immune function. So recently, research has demonstrated a strong link between carbohydrate ingestion and cognitive function. And that's relatively unsurprising because the brain's favored fuel is actually glucose. So it's thought that glucose uptake by the brain is reduced at 3.6 millimoles per litre. Blood glucose concentrations of 3.6 millimoles per litre. It's also thought that cognitive performance is thought to decrease at 3.4 millimoles per litre. So while it's unlikely that such low blood glucose levels will occur in a well-fueled athlete, it has been such low blood glucose levels have been reported within athletes. So that just shows how much of a significance this might have. And obviously, it probably has more of a significance on tasks or activities or sports that have that cognitive component. So decision-making, reaction times, concentration, that kind of thing. So obviously, that will have a significant effect on performance. It's also been the rebound hypoglycemia phenomenon has also been discussed widely within the literature. Asker, you can summarize the topic neatly on his website. So rebound hypoglycemia is essentially relates to the interplay between the effects of carbohydrate intake, the glucoregulatory hormones, and exercise. So its impact on performance has been widely debated, but the general consensus is that it's unlikely to significantly impair performance. But obviously in an era of marginal gains, it's potentially something to consider addressing. And Mark Russell has done a great job of summarizing the potential solutions in his paper, that Halftime Strategies to Enhance Second Half Performance. So I know that I have personally implemented many of Mark's recommendations successfully, including the manipulating the manipulation of the timing of carbohydrate intake, and the manipulation of the glycemic index of the carbohydrate provided. So while I don't have any data to support the ergogenic effects, it certainly hasn't harmed performance. And when you compare, the benefits of manipulating the timing and glycemic index to the potential negative effects of dizziness, weakness, and nausea, obviously it's fairly easy to understand what the better option would be. So another interesting area when discussing carbohydrates in the brain is the impact of carbohydrate intake on neurotransmitter synthesis. So a neurotransmitter is essentially a chemical signal in the brain that controls actions and emotions. So the primary neurotransmitters are serotonin, dopamine, and acetylcholine. So way back when, it was shown that the brain neurotransmitters can be synthesized from amino acid precursors, and therefore the diet can have an influence on neurotransmitter synthesis. So I'll try my best in the next few slides to summarize the mechanism with this kind of crazy looking diagram. So if you just take this diagram as it is, so the blue dots represent glucose, the purple dots represent the branch chain amino acids, and the yellow triangles represent tryptophan. So tryptophan is a large neutral amino acid. Now there's obviously more stuff floating around in the blood, but for the sake of this example, just play along with me. So when you eat a large dosage of carbohydrate, or a large dosage of high glycemic carbohydrate particularly, I think along the lines of like mashed potatoes and orange juice, obviously not that you'd ever consume mashed potatoes on its own, or you might consume orange juice on its own, but anyway, just play along. So your blood glucose rises rapidly following the consumption of that carbohydrate, and obviously the rapid rise is detected by the body, and the body releases insulin in a dose-dependent manner. So imagine insulin being similar to FedEx in a way. So obviously FedEx facilitates the delivery or the transport of letters and packages from one place to the other. Insulin essentially does a very similar thing, but with blood glucose. So insulin facilitates the transport of glucose out of the blood and into the surrounding tissues. And it also prevents further glucose being released into the blood from the liver, so it prevents glycogenolysis in the liver. So because you've consumed a large dosage of carbohydrate, the quantity of insulin that is released is also large. So this whole process recurs rapidly and generally results in your blood glucose crashing back down. So hence the name rebound. So that's where the rebound hypoglycemia comes from. So you consume a large dosage of carbohydrate, insulin is released dose dependently, and obviously that results in a marked reduction in blood glucose because glucose is removed by FedEx rapidly, and your blood glucose levels go crashing back down. So not only does insulin facilitate the removal of glucose, but also the branch chain amino acids. So obviously when insulin is released, blood glucose is removed from the blood, but so too are certain branch chain amino acids. So the BCAAs, insulin facilitates the removal of the BCAAs out of the blood as well. So now all that's left in the blood is the large neutral amino acid tryptophan. So the ratio of BCAAs to large neutral amino acids has been reduced. This essentially increases the likelihood of tryptophan passing the blood-brain barrier. And the significance of this will become a little bit clearer in the next slide, hopefully. So obviously here we have, because the concentration of tryptophan has increased in the blood, well, it's not necessarily increased, but the ratio of BCAAs to tryptophan has reduced. Tryptophan is more likely to cross the blood-brain barrier. So I'll just quickly run through this again because it might not be that clear at this stage. So I'll use a slightly different illustration. So again, you start with a high carbohydrate, low protein, low fat, and low fiber meal. So this results in a rapid rise in blood glucose levels. So obviously that meal will provide a significant amount of sugar or glucose to the blood that will become present in the blood. The body will detect that and release the glucoregulatory hormone insulin. Insulin functions in a similar way to FedEx. It facilitates the removal of glucose out of the blood. So that will occur, so the removal of glucose will occur, but so too will the removal of the branched chain amino acids. So the ratio of tryptophan to BCAAs increases, so that obviously increases the likelihood of tryptophan passing the blood-brain barrier. So interestingly, tryptophan is the amino acid precursor of serotonin. So once in the brain, serotonin synthesis actually increases. Serotonin is known to have a sedative-like effect on the body, making you feel quite sleepy, relaxed, and lethargic. You might have experienced this issue, particularly at Christmas time or Thanksgiving here in America, potentially without even knowing what's happening. So a carbohydrate-rich or Thanksgiving-rich dinner a carbohydrate-rich Thanksgiving or Christmas dinner, followed by a nap on the sofa a few hours later. Essentially, that's because you've increased serotonin synthesis in the brain, which has resulted in you feeling fairly sleepy, relaxed, and lethargic. This is also similar in a way to the central fatigue hypothesis that was being touted many years ago. So, yeah, the serotonin issue was also similar in a way to the central fatigue hypothesis. So you're probably wondering what relevance this is to us in a sport performance blog, but it's important to consider when this might be beneficial and when it's obviously not going to be beneficial. So when we think about sleep, sleep is obviously critically important to recovery and performance in general. And any means of promoting better sleep is obviously a viable option. So I know Shona Halson neatly summarized this whole mechanism in her sleep nutrition paper a few years back. And it can be beneficial, particularly before games, when sleep can be potentially troublesome. So obviously the day before a game, the athlete's mind might be racing, thinking about the following day, the game the following day. So that might result in a degree of or potential issues in relation to sleep. And any way in which you can increase feelings of lethargy and tiredness, that will be beneficial. So the addition of a pre-sleep carbohydrate-rich snack could really benefit in reducing sleep onset latency and potentially even increasing sleep quality. So I know I've talked about it before in previous posts and previous blogs, but Louis van Gaal actually copped some stick for introducing a or a pre-bed snack or a pre-bed supper. He made it obligatory, so it was a compulsory team event the day before a game. Players had to go down and report to this snack, and they were provided high carbohydrate meals, and that would actually align with my recommendations as well. So if they consumed that high carbohydrate meal, they're actually likely to increase serotonin synthesis. But obviously it's fairly important that you keep the protein content and the fat content and also the fiber content fairly low, because obviously the protein will contribute some branched chain amino acids, which will obviously normalize the ratio of BCAAs to tryptophan, which will kind of and BCAAs will compete with tryptophan for uptake by the brain. So we want tryptophan to be increased in the brain, so you increase serotonin synthesis. So reducing the protein content of the meal will be beneficial. And reducing the fat content will also increase the rate at which the meal is digested. So obviously that's going to be beneficial. Interestingly, I've also had a scenario where a player struggled with sensations of lethargy and tiredness before kickoff, following the pre-match meal consumption. So after some consultation, it became obvious what the issue was. So he was consuming a large quantity of carbohydrate, so that obviously aligned with my recommendations with a pre-match meal, but he was actually consuming little to no protein, fat, or fiber. So obviously, as I mentioned previously, protein will provide BCAAs to normalize the ratio of tryptophan to BCAAs. And keeping fat and fiber intake low is probably a good idea from a digestive perspective, or from a digestion perspective. But including including small amounts, will actually slow the rate of digestion and dampen the glycemic response. So just a simple alteration to the composition of the meal that he was consuming in the pre-match meal resulted in him feeling and playing much better. So obviously that mechanism does have relevance to real world to real world practice, and I've utilized it within my practice professionally as well. I know it's fairly heavy science and the mechanism is kind of complex, but there is definitely more to carbohydrate than just fueling the muscle.